Hey guys, so we're moving into 3.3, proving lines parallel. So before we were talking about when we know lines are parallel and what relationships were established. So now what we're going to do is we're going to talk about how to prove the lines parallel. Proving. Knowing that certain angles are congruent. Okay, so these are all converses. All right, and I gave you this little slip today. I'm sorry, period 3, I forgot to give it to you. I can give it to you tomorrow. And I'm trying to zoom and get the right angle here. Sorry, having a couple little issues, technical issues. Okay, so the converse of the alternate interior angles theorem. If two lines and a transversal form alternate interior angles that are congruent, then the lines are parallel. So that's basically saying that if you know that you have a set of alternate interior angles that are congruent, then you can say the lines are parallel. All right, that's the converse of alternate interior angles. Then we have the converse of the alternate exterior angles thing. It's basically the same thing. If you have two lines and a transversal that form alternate exterior angles that are congruent, then the two lines are parallel. So our goal is to prove lines parallel, but we're going to need to either see that their alternate interior angles are congruent or their alternate exteriors. All right, right here, I have the converse of the corresponding angles theorem. All right, so just like the other two, if two lines and a transversal form corresponding angles that are congruent, then the two lines are parallel. So the corresponding angles, remember those are the matchy-matchy ones? If they're congruent, then you can say the lines are parallel. And then lastly, we're going to move down here to the converse of consecutive interior angles, which we've also been calling same-side interior angles. Remember, those are the two angles that are supplementary, or the pair of angles that are supplementary. And again, if two lines and a transversal form consecutive interior angles that are supplementary, then the two lines are parallel. So all of these, converse, it's all to prove lines parallel. Let's look at an example of this. But first and foremost, and the most important thing, vertical angles do not prove lines parallel. If you see that, hey, they're vertical and they're congruent, no, those do not prove lines parallel. Never, ever, ever. Vertical angles do not prove lines parallel. All right, so here is our proof. Given that angle 1 and angle 2, they're congruent, okay? Hey, they're telling you they're congruent. They want you to prove that line P is parallel to line R. All right, so what we're going to do is we're going to write our given. Angle 1 is congruent to angle 2. And then I'm going to write angle 3 is congruent to angle 2 because they're vertical angles. And then I'm going to write angle 1 is congruent to angle 3 because of transitive, right? Angle 1 is congruent to 2. Angle 3 is congruent to 2. Oh, they're both congruent to 2, so I can say angle 1 is congruent to angle 3. Because angle 1 is congruent to angle 3, I can say that P and R are parallel based on the converse of corresponding angles theorem. So based on the fact that angle 1 and angle 3 are corresponding, I can say the converse of corresponding angles theorem to state that line P is parallel to line R. Okay, then right here we have this example. Given the information, determine which lines are parallel and state why. All right, I'm going to look at A and B first. Let's see if I can get all of this information in here. Okay, so angle 1 is congruent to angle 11. All right, those are alternate exterior angles. All right, angle 1 and angle 11. And because they're alternate exteriors, I could say that line L is parallel to line M based on the converse of the alternate exterior angles theorem. So converse, 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 whenever we're trying to prove lines parallel. All right, next, the measure of angle 6 plus the measure of angle 13 equals 180. That's what it's telling you. Okay, so now the measure of angle 6 and the measure of angle 13. All right, these lie on these lines right here. So I could say that L is parallel to M based on the converse of same side interior angles theorem. Same side interior angles theorem. All right, and then if we look down, angle 12 is congruent to angle 14. Well, angle 12 is right here, and angle 14 is right here. All right, that would make lines P and lines R parallel based on the converse of alternate interior angles. The converse of alternate interior angles. And then lastly, D. Angle 4 is congruent to angle 12. All right, right here is angle 4 and angle 12. Well, those would make lines L and lines M parallel because they're corresponding angles. They're matchy-matchy. Lower left-hand corner, lower left-hand corner. L and M would be parallel because it's the converse of corresponding angles theorem. All right, that's it for today, guys. Or for 3.3. 3.4 coming up next.